week 10, second lesson, second half. In the first half of the lesson, we discussed a program that was previously introduced in week 7. And we look at the back end and how we interact with back end by sending get request for entire table and one item get request, sending put request to update one item, send a delete request to delete one item, and we send a post request to add one item to the table. And we also look at how status change when there is an error and when there is no error. We did it with a service created by a GPA repository, a Restful service using a GPA repository. This example is elementary. It contains only one table. And another step today is to look at more complicated example that contains several interrelated tables. Although it is a longer example, but it is mostly self-explanatory, so it won't take long to explain. But before we go there, let's discuss theory. What is Restful service and why we use it? I posted introduction slides in today's lesson in this week folder. It is called Basic Principles of REST. So RESTful services are quite common, and there are a lot of information about RESTful services because this is where technology goes. But it is just introduction into the ideas. So let's discuss these slides. It will take about 15 minutes. There is not a lot of slides, and there is not. It is general idea about RESTful services. There are several kinds of web services, services for data, web services. There are two most popular ones. Simple Object Access Protocol, SOAP abbreviation. It is originally introduced by Microsoft, and it is was like primary choice up to the time when RESTful services became popular. SOAP services are using XML communication in standards for data. In recent years, another standard came up and became hugely popular. It's called Representational State Transfer Protocol, REST. And it became very popular alternative to SOAP. One of the reasons why, because if we use SOAP is limited to XML, and RESTful services are not limited to XML. So they use it for JSON, to transfer JSON, and JSON is very easy to parse in JavaScript, since JavaScript is the most popular language right now. This is the reason why probably RESTful services are so popular. Another reason that why it is popular, it is easier to scale on web. And so we're going from a small application to bigger web application to even bigger application is easier to do if we use the RESTful services. So let's look at what is the basic principle of RESTful services. RESTful services use uniform resource identifiers like URI to set addresses of the data. So conceptually, resources are separated from their representation. We use URI for address of the resource. And representation, it is whatever is sent to us or what we send there. And what do we send there? Data. But RESTful protocol is not fixing what kind of data we send. But obviously, it should be some popular format that is easily parsable and easily creatable. So there are two typical popular formats, XML and JSON. So although RESTful protocol is not fixing what kind of data we send, we could send plain text if we want. Typically, it is one of the two, either XML or JSON. Another distinctive property of REST is that clients interact entirely through hypermedia. What is so hypermedia provided dynamically to clients. So besides data, it also will provide data about data in hypermedia links. They inserted automatically on the server side. If you write code yourself for generating JSON, you will also need to edit, but with help of libraries, it's not that difficult. So besides data, RESTful services also provides data about other data. So you go to root of the service, and besides current data, it will also show links to other data. This is what you saw in student data example. So besides showing current table, it also provides link to other data that is related to it. When we run second example that will have more tables, we will see all those links between those tables inside of JSON. So this kind of links or extra data, how to find data, is called hypermedia. And this data inside of the data is called hypermedia. Hypermedia as end concept is called as hypermedia as engine of application state, HTS. There is no standard how to pronounce HTS. Most people just hate HTS, not HTS. HTS. So it's this is what it means. So besides data, it also provides links to other data in it. And what we have client-server separation. We have a client that can consume data and servers that provides data. So this is client-server model, enables, embraces a separation of concerns like data and data service end and user interaction end, GUI end, or client end. So why it became so popular? There are two primary reasons why RESTful services became so, or web services in general, became so popular. First reason, it is flexibility. And second, it is scalability. There are other reasons, but these two are the most popular. Flexibility. When we separate data end from client end, the whole system becomes more flexible. If we have just clients, server-side programs that insert data into templates from the database, and if we want to write a mobile app that accesses the same data, we will need to write another backend specifically for the app. We cannot use the same backend for both. So when we separate backend from front end, we can reuse backend for different interfaces. For JavaScript program, for iOS program, for Android program. So it is flexibility. Second, because they are separated, we can change front end and back end independently. For example, if we want to create another version of backend, like version 2 protocol, whatever, and create another, say, another front end that is using it, they can still use, say, the same data. And if we want to change front end, it does not necessarily involve changing backend if we maintain the same protocol. Another is the second reason why it is so popular. It is, besides flexibility, it provides easier scalability. Due to the nature of this protocol that we will describe at the next slide, it is easier to scale applications from say, for smaller size to bigger size in terms of traffic. Because when we use RESTful protocol, we can increase number of servers serving the data. This way, we can go from, say, apps that are used by small number of people to apps used by larger number of people by scaling backend. So that's the reason it is why it's so popular. It is easier to scale applications without rewriting code. And it also reducing complexity in the apps. Why it's easier to scale? Because by definition, RESTful protocol is stateless. It means there is nothing about user state is saved on the server side, except login. When you log in, obviously it is saved somehow, right? It is sending you token that gives you access to the data. And login can be handled by separate server. So it doesn't have to be the server that is providing data. So it does not, say, create extra traffic, because you just log in, and after this, you use data. Just because RESTful services are stateless, they don't store state of a user, like what is the current page of the user, what user clicked, this is what it means. It doesn't store any state of the user. It means data can be duplicated. Duplicated through several servers. So when a user sends request or a client sends request, it sends to specific address, and load balancer will decide which server will respond. So when we talk to server side and large scale application, we don't care who is responding. We need to get response, and we will get it. And who is deciding who will send response? Load balancer will decide. It will decide which of the servers is less loaded, so it will forward request to that server, and that will respond. Just because, again, just because it's not storing user state, it is just giving data based on the request. All the data can be cacheable. So it means we can, using caching capabilities that comes with HTTP protocol, using current HTTP standard. So technology that is using to duplicate HTML can be used to duplicate HTML through caching servers. It can be used to duplicate the data this way. So this is what it means. Since REST typically using HTTP, it inherits all caching properties of HTTP offers. So it is, again, it is efficiency of the server side. So we will end up is, in larger scale applications, we will end up with layered system. When we have clients and servers. And clients are not aware which specific server they are interacting with. This property allows introduction intermediate servers, for example, to handle security. So it could be separate server, and load balancing capabilities. So several servers will reply, and so load balancer will decide which of them will be less busy and reply to you. So on the server side, RESTful services can be layered. And they also can provide code on demand, like JavaScript. And obviously, this program doesn't do it. That will say, for example, JavaScript can be provided to web-based client to customize some functionality. So this introduction is based on two books. from our library. And first, it is building RESTful web services with Spring. It is quite thin book, easy to understand. Conceptually, it has code examples. And another program, another book, it is RESTful web services with Spring 5. And also, it is in our library book. So that was general introduction into RESTful services, just in words, why it is popular, why it is used. Next, we have about half an hour before end, and it's enough time to discuss another example, another RESTful service that came from a book. It is Yuliana Kosmina textbook about certification for Spring 5. So please clone it. I will also clone it because I didn't clone it on this laptop. It is in week 10. And this is pet sitters. I click pet sitters. It takes me to GitHub. I click code, and I click copy. And now I will stop this app running. I will close the project because I don't use student data today anymore, this student data. So I close this project. And I will clone code from the GitHub. So I go to get from version control system, get from VCS, and I do Control V. So I clone pet sitters app. I created this app exactly the same way as student data. But not all code is mine. I had empty app, created as I explained, and then copy-pasted code from the textbook. And I edited it, so it's not original code. But most of it is as it is. So it looks like it is already cloned. So let's see what is inside. In Java folder, we have ents. This is how she called it, entities. And we have pet, request, response, review, and user. And we also have abstract entity. In our projects, when we defined entities, we didn't use inheritance. And this project is also using Java Persistence API. There are several ways to use inheritance in Java Persistence API, implement inheritance in Java Persistence API. She used it in one of the most appropriate way here and easiest way. She defined abstract entity, and she inherited all entities from abstract entity. Abstract entity, in this case, defines paths that she wants to be in every table. In this case, columns that she wants to be in every table. She created ID. Obviously, primary key should be in every table. So she created an abstract entity that contains primary key, ID. Also, she created date and field table column name created add. When we add a row, we will insert field when this row was added. So when we, it is just kind of bookkeeping option. So she's inheriting from entity that contains created add. So every table will contain when this entry is created add. And also she is inheriting modified add. So when data is changed, this column will also change when this row was modified. What is JSON ignore? You saw that repositories are creating JSON automatically. If something is if some entry in entity is marked with JSON ignore, this path will not be inserted into JSON code. So this is meaning of JSON ignore. So let's run this project and see what it does. It is using H2 database. Originally, it didn't use H2. I changed it code for H2 for simplicity. I think it used MySQL originally. I'm not sure, but not H2. I remember changing it. And when we use H2, there is a console that we can access when we go to localhost 8080. This program doesn't have any HTML, so I created index.html just with word home in it. So I'm going to h2-console. h2-console to see tables that are generated. So I can click connect. It doesn't connect. This is wrong piece. This one is wrong. It should be something else. So let's find out what it should be. It is in configuration. I'm going to resources, application properties. This part, this one. From application properties, supposed to be this one, I believe. Connect, yeah. And this, I don't know why it shows test. So I connected to it, and I see tables. Table for pets. So we have only 3 pets in it, so it is just some data. Table for post requests, like user can post request for specific pets, specific time. I need pet sitter. Table to post responses. There's somebody responding to that request, and yeah, I can sit with your pet on that day. Review. It is about reviewing responses and requests and users who log it in. So let's discuss this in details. And there is also a table, request pet. So what this request pet table is about? When you studied databases, you learned that in relational databases, if we have one-to-one relationship, technically you don't even have to have two tables. It can be just one table. Or if you want to have 2 tables, you can just deal with one foreign key, right? You don't need to create a third table. And if we have one-to-many relationship, you also code it with foreign key, right? So if it is one-to-many, on the side which is many, it will be foreign key. This is ID of the side which is 1. The same as many-to-one, it is just backwards. But when we have many-to-many relationship between 2 tables, we have to create extra table that will contain 2 foreign keys from each side. In this case, we have many-to-many relationship between pet and request, user request for pet sitting. Why is it many-to-many relationship? A request can contain more than 1 pet. For example, user can have cat and dog and wants somebody to pet sit cat and dog, or 2 cats with different names. So a request can contain many pets. And the same pet can be inside of different requests. For example, user wants a pet sitter for Monday and maybe next week on Saturday, right? So it would be 2 separate requests. So with the same pet may belong to different requests. So indeed, we have a many-to-many relationship between requests, pet sitting request, and pet. Just because we have many-to-many mapping or relationship, we have to have a table that contains 2 foreign keys, from 1 key from each side for many-to-many mapping. All those tables are generated automatically. We don't have a code for it. If we look for schema.sql file, we will not find it. There is no schema SQL. There is no also data SQL file. So it is handled differently. How did she do it? First, I commented out GPA Hibernate DDL outer none. So I commented this line. That was turning off automatic generation of tables. So if it is not commented out, it will not generate tables automatically. I commented out, now it will. It will generate tables based on entities. Define it. There are entities. So when system starts, it will generate tables based on that, if tables don't exist. Where the data is coming from? She created a file, let's in utils, call it, no, it's not in utils. Let's find where it is. In init. It is in init, and it's called DB initializer. And it is bean. It's marked with service, so it is bean. A system will create it when necessary, and not necessary. When it starts, it will create this object. And when object is created, it will inject, in this case, user repository. Out of it means inject. And it is field injection. And post construct, it's a mark of a method that will be executed after things already connected. So after constructor is called, after user repository is injected, system will call post construct. What did she do here? She is adding data using Java code. So the data is coming from Java code. So it's not data SQL as we did it, and it is just through Java. We could do it as well because it works, obviously. We just decided to put a SQL file. So this is how she populated these tables. So let's see hypermedia. Let's see the code. So where is the rule? Where is the root of the data? I put this inside of description configuration, where it is properties, application properties. Here it is. It is the same, /API. So this would be base path of the data. So I'm going to localhost 8080 /API. And this is hypermedia description of it. We see table for pets, table for users, table for requests, reviews, responses, and this is generic. When we go back, it will be the same. So let's see pets. This is a pets table. Every pet has link to owner. So this is the pet ID, and this is owner. And to table of requests. So this is one. In this case, a pet has only one owner. This is the way how it's coded. But pet can be part of several requests for pet sitting. So request for this pet is a table. That could be empty, but it's a table. So this is how it works. This is all pets. This is pet with specific ID 1. This is the same. It is self-reference, and this is pet reference. This address is for owner, data about owner of the pet. And this is address of the table where all requests for the pet sitting of this specific pet. So this is how hypermedia works. We can go to owner of this pet one. So I go here, and this would be data about owner of pet one, John Cusack, right? And this is ID of the owner, so it is the same place. So if you go to this address, it will be the same piece, but access it differently because it is linked from pets, but this is a link directly to owner. This is a table of responses of this user. As, for example, user saw request and put some responses. Yes, I can sit with this pet, that pet on specific days. So this will be responses of the user table. This is request of the user table of requests of the user that this user wants to have pet sitting for his or her pets. And these pets, see these pets, it's a table of pets of the user. So this is an idea about hypermedia. So it is not just data about specific user, it also has links to other data related to the user. So it is browsable. And if we use, if we generate HTML pages, for that, there is option to do it. It will be actual inside of pages data. So as exercise, we can do it later. So this is how hypermedia looks like. It is not just data, it's also data plus link to other data. So it is discoverable. Next, let's look at the code. Abstract entity is inherited everywhere, including user. A user is here, and this is table name. I don't know why she prefixed all tables with p underscore. I don't know what this p means. Maybe I don't know. She did it so. So this is a table name. User, this is a constraint, not empty. Can have first name, last name, right? Password. User type, and it is enumerated, and it is either owner or both or sitter, right? Pet sitter. And mapping. JSON ignore. So this part will not appear as inside of JSON as a set inside of it. But it will appear when you retrieve entity in your Java code, which is important. So from user to pet, it is one-to-many mapping. So one user can have many pets. And when you retrieve object from database, this request will also pull set of pets from another table. So you will retrieve not just user, you will retrieve user and all pets of the user. So it is, in terms of SQL, it is multiple requests. In terms of GPA, it is one API calls. API call. So when you retrieve user object, it will pull out all pets objects from pet table. Also, requests, also one-to-many, because user may leave several requests. Also is the set. When you pull user, it will also pull request of a user and responses. So user table is relatively, user implementation is relatively straightforward. It is one-to-many all the time. One user, many pets, one user, many requests, one user, many responses. Pet. I remember that one user, many pets. From pets side, it is many to one, because many pets for one user, right? From pet side, it's many to one. And in this case, okay, let's go back to user, because I didn't specify that one. Okay, this one, one-to-many mapped by owner, right? So this is idea of a owner ID foreign key in pet table. So this is foreign key in pet table, owner, this one. When we go to pet, this is foreign key in current table to user. So it is user owner ID. Okay. No, sorry, foreign key. It is owner. It's not, sorry. Okay. I said it's foreign key. It's variable. It's variable. It's not foreign key. It's variable here. But this is foreign key. Because join column, this is foreign key. But this is, sorry, it's meaning is foreign key, but it's actually variable name, mapped by. What is cascade means? Persist means when we save user, it will also save pets that you change it as the paid data that you associate with user. Remove means when you delete user, it will also delete all pets associated with the user. So it will maintain data consistency also. Now let's go back to pet. So this is foreign key to owner. And when you retrieve pet, it will also retrieve owner object, link it to the pet. What else in the pet? There is also many-to-many relationship between pet and request. So this mapped by pets, this is variable inside of on request side. And in this case, it's we have when we pull pet, it will also give set of requests. You can specify it as a list or set. It's up to you. If you specify it as a list, it will be given as list. If you specify as a set, it will be set. When we go to requests, remember that relationship between request and pet, it is many. So at some point, we need to specify table, right? This is a name join table. Because it is many-to-many relationship, we need to have an extra table to implement this relationship. So this is a table that is doing this many-to-many relationship. And we specified foreign keys in that table related to both sides. And when we pull a request, this request object will contain set of pets that included into this request. Like I want to get pet seated for my cat name, something, and dog name, something. So as you see that Java PC Instance API is extremely flexible. And many things come by default. But what comes by default, it comes at the expense of learning how to do it, right? So it does require going through and understanding how to do it. It's hard to remember, so most people just look up when they need it, either from the examples or from documentation. It also contains interesting part, this example, like this, it is just default, right? Similarly to Android, if we need to write specific requests, a specific query, we can write it on top of methods that we want system to implement. What is the language? Language of the query is not SQL. Similar to Android, when you write query on top of method inside of DAO class, it is not pure SQL, right? Because you have a space holders where you insert variable. What we have here in queries on top of the methods of the interface, it is special language called JQL, Java PC Systems API Query Language. I believe this will JQL? I think it's so. We can look it up. So this language is not SQL, but quite similar, and it is cross-SQL language. So it means if your database is MySQL or H2 or whatever, it is the same language for any database. It's a database-independent language. So Java Persistence API provides object-oriented access to any SQL database except SQLite. It's not implemented for SQLite. I don't know, maybe this is why Android is not using it, because it's not implemented there. It is almost any database is supporting Java Persistence API, and Java Persistence API comes with own query language. If we need a little more than just retrieving and saving objects, we can use this language. I think it's JPQL, not JQL, JPQL, Java Persistence Query Language. To do queries for specific parts. So we can just do not play. JPQL. Yeah, Java Persistence Query Language. This is what it means. So not JPQL, JPQL. And Java Persistence Query Language. And it is standardized. And there are tutorials, documentations. And if you write code for Java backend, this is a place to invest your time. How to deal with creating repositories and service, how to create tables and relations using Java Persistence API and JPQL language. Questions? No? So this is example beyond elementary, obviously. Please browse through the code, see how it works. And it is demo how to write backend with several related tables, and they're related multiple ways, right? Many to many, one to many, and many to one. Right. Questions? No? So let's finish.